Hello, my name is Mitchell Walker. I am now an associate professor in the Aerospace Engineering School here at the Georgia Institute of Technology. I come from the University of Michigan. I have a bachelor's, master's, and PhD all from Michigan in the area of gas dynamics in the Aerospace Engineering department there. So to do any sort of in-space propulsion research on the ground requires a vacuum facility. While we can't turn off gravity or create the zero-G effect, we can remove the atmosphere. And we do that here at Georgia Tech in two large vacuum facilities. One is 14 feet in diameter and 22 feet long, and the other is 16 feet and 30 feet long. And what we can do inside those facilities is while the rocket engine is running, we actually remove all of the environment and we remove the exhaust products as they are ejected into the facility. So the engine effectively thinks that it is in space, and then we can take measurements from there to understand how the engine is ionizing the gas and accelerating. So at an academic institution, you have to look at the goal. What are you trying to accomplish with your students? You want them to be good citizens. You want them to be ethical and high-performance engineers here in aerospace engineering at Georgia Tech. And at the same time, you want to give them the ability or give them the framework to develop a fruitful career. And so this comes down to, one, are you teaching your students to be good citizens? Are you teaching them to engage problems that will impact in a positive manner the rest of the country, if not the world? Now, it's a global environment. And at the same time, are you giving them the basic foundation in which to do these things? And what we tend to focus heavily on here is a foundation in aerospace engineering, but we do cover those other components in the development of the students. On that foundation level, a lot of that really happens in the classroom. We need to ensure that the students have a solid background in calculus, chemistry, physics, and then once we have that background, we can begin to grow it and apply those things that they've learned to aerospace problems. And by aerospace problems, we're looking at fluids and combustion and propulsion and structures and dynamics, flight controls. How do we give them a foundation in physics and chemistry and calculus, and effectively, and allow them to, or show them how to apply that to real world problems? What that really comes down is, can we teach the students to apply conservation equations, conservation of mass, momentum, and energy, as well as entropy, and their background in physics to real world problems? So a lot of our courses really focus on these are the conservation laws, this is a problem, this is how you apply it. And so we have basically a system of, we're going to lecture or show you videos or do something in the real world to show you what the problem is, what you're trying to tackle. And then from that level, we'll show you how to apply the conservation equations in physics to those problems. And then through the homeworks or problem assignments or group projects, we allow the students to apply them. And then we give them feedback, of course. And we try to make that cycle happen the optimum number of times during a semester so that the students can really learn to use the materials.